Okay, guys, this is the second video, hopefully, that you're watching related to Checkpoint 1 for Don't Feel the Heat. And the purpose of this video is to kind of discuss the content a little bit with you. I want to say right off the bat, feel free to reference any other resources if you want to go on YouTube and find some other videos. I'm sure there's other teachers out there who can explain this even better than I can. Watch the Eureka video that is on the heat, temperature, and thermal energy document that you're filling out, and Google any questions that you have, talk to your parents, find a science textbook around. But I just want to briefly go over some of the content that you are going to be learning about in this. So we have to start with some definitions, and honestly, that's the most important piece here because a lot of these concepts are not that difficult. It's just the terminology is a little new from what we're used to. So this also goes along with that document because they're gonna ask you right in the very beginning for some definitions. So I think the first one they ask you about is what a particle is. What's a particle? Easy definition for a particle is just a small piece of matter, right? And you can get into much more intense definitions than that, but for our purposes, it's just a small unit of matter, molecule or atom or whatever, right? The next term they're going to ask you for is kinetic energy. So what is energy? Right off the bat, energy is the ability to do work. So a lot of different things can do energy, and there's a lot of different types of energy. So specifically, what is kinetic energy? So when we're talking about kinetic energy, we're referring to motion, right? Kinetic is referring to motion. So kinetic energy is the energy of an object because of its movement, right? Because of its speed or velocity and its mass. So the bigger an object is, just like we talked about in the last unit, the more force is going to be needed to move it, and all that's really much less important than understanding that kinetic energy is related to the movement of a object. And in talking about this topic, when we're talking about kinetic energy, our objects we're referring to are its individual particles, right? So within a pile of snow or a cup of hot chocolate or any number of things, the kinetic energy can be measuring the specific particles within that. The next term it asks for is thermal energy. So thermal energy is related to kinetic energy because it is the total amount of energy that a substance has because of the particles in that substance. So kinetic energy is referring to just one particle. The thermal energy is referring to all of the particles in a substance, the total. So the more particles you have, the more kinetic energy you have, the more thermal energy you have, right? The more particles you have, probably the more thermal energy that you'll have. Or if you're comparing the same substance, less particles, less thermal energy, more particles, more thermal energy. Let's see, the next thing it's asking for is temperature. This is a really tough one because we use the word temperature all the time to mean all sorts of different things. But when we're talking about temperature in science, all we're saying is it's the measure of the average kinetic energy of the particles in a system, right? So we're not measuring, we don't have the skills or the tools to measure the kinetic energy of any individual particle. So we're just going to take the temperature, and that's going to give us the average of all the particles inside, right? Not any one specific one, but we can say what one probably is, or what the average of any individual one would be. So that's what temperature is. A measure of the average kinetic energy of the particles in a system. I'll say that again nice and slowly. Temperature is a measure of the average kinetic energy of the particles in a system. So if you think of one water molecule in a glass of ice water, the average of that, even though some parts are going to be warmer and some parts are going to be cooler, so some parts are going to have more kinetic energy and some parts are going to have less kinetic energy, say you have ice cubes or whatever, the temperature of that cup is measuring the average kinetic energy of each of those particles. And then finally, then what is heat, right? So heat is defined as the transfer of thermal energy. So it's always going from a substance of higher temperature to a substance of lower temperature, or from a warmer thing to a cooler thing. Energy always flows from the hotter to the cooler. And when energy is flowing, that transfer we call heat, right? So heat is not the same thing as temperature. Heat is a measure of the transfer of energy, thermal energy. I know, this is kind of out of control. So at this point, you should have watched the Eureka video. There's a link to it in the document. If you haven't done that, I would pause this video right now and go in and watch that, because that is going to help you with the next part, filling out the analogy. So in the video, okay, I'm going to assume you guys all watched it and now you're coming back to this. In the video, it gives really helpful analogies of each of these different terms that we kind of talked through. So what do the particles, what do the bills of money in the analogy represent? So each individual bill, whether it was in the cup or in the bucket, each of those represented a particle, right? Particles. What did the value of the money in one bill represent? So for each bill, how much that bill was, whether it was a $50 bill, $100 bill, what did the value of that bill represent? That represented the kinetic energy of that particle, right? The kinetic energy of that particle was represented by the value of the bill. So the higher the bill, the higher the value of the bill, the more kinetic energy that particle was kind of said to have had. What was the average value of the bills in the system? That is our way of measuring temperature. So that represented temperature. So what that's saying is, if you have the cup that was filled with money, right? Some of those bills might have been $100 bills, and some of those bills might have been $50 bills, and some might have been $20 bills, but maybe most of them were $100 bills or whatever it was. So the temperature of that was the average bill that you would expect when you're pulling it out, right? Not a perfect correlation, but good enough for the analogy. The next thing on here is, what's the total value of the bills in the system? So what is that representative of? The total value of all of the bills in the system, whether it be all of the bills in the cup or all of the bills in the bucket. Well, the total value is representative of the thermal energy, right? Because thermal energy, as we discussed earlier, is the total energy in the system, right? The total energy, kinetic energy of those particles in the system. So the more particles you have, even though they might be smaller or having lesser kinetic energy, the more particles you have, the more thermal energy you have. So if that's why they asked you in the video, would you rather have a bucket of $50 bills or a cup of $100 bills? Even though the cup has higher valued bills in it, there are less of those, so your overall value is lower, right? So you should choose, if you're going for the most money, you should choose the bucket of $50 bills with a lot more than double $50 bills, because that's a higher money value, and so it represents a higher thermal energy. And then the last thing is giving money. Giving money to someone is representative of what? And that's representative of heat, because remember, heat is the transfer of energy, of that thermal energy. So if you're giving money, you are representing heat. Okay, let's see what the next thing on here is. Okay, so if this video didn't make complete sense to you, watch it a couple of times over again and pause it and take notes on each of the little things that I'm saying, because a lot of this just, you need time to let it sink in and let it understand it. Use your mind map, add to it, give examples, right? This doesn't mean this, it does mean this, circle things, arrows, anything you need to kind of make sense of all of this, because the more you can interact with the information and understand the analogy, the better off you're going to be. So when you get to the next part of the of that challenge, part 2, comparing thermal energy and temperature, it's going to ask you to draw pictures to represent molecules and movement of those molecules within the object. So the first one was a snowball compared to a pile of snow. And I did this one for you, though it's not super easy to see. So I'm comparing, sorry, the lighting is not great in here. I'm comparing the snow in a snowball to the snow in a pile of snow. And if you look closely, you can see that the particles are the same size, the particles are the same distance from each other, and the particles are moving at the same pace, or with the same speed. And you can tell that because I use little vectors, right? The magnitude of those vectors are the same. I drew a little key down here. So the particles are the little dots, and then the arrows represent the kinetic energy of each particle. So the kinetic energy of each of those particles is the same, about, which means those two items, the snowball and the pile of snow, are the same temperature, right? However, which one has more particles? That's right, the pile of snow has a lot more particles of snow in it, or molecules of water in it. So if we're adding up the total energy, the thermal energy, which is the total kinetic energy of each of these, we're going to have a lot more energy in this system than we are in this system. And that is kind of the main point that they want you to take away from this, is that thermal energy is like the overall value, right? The overall energy that you have. Whereas kinetic energy measures just one specific particle, and temperature is the average, what each particle would be. Thermal energy is all of them combined. What is your overall energy? So the more particles you have, the more energy you have. The toughest one on here, in my opinion, is challenge 3, because you're comparing really, really quickly moving particles in hot chocolate to really, really slowly moving particles in snow, but you have a lot more particles in the snow. So which of those two things has more thermal energy? And so my hint to you for this is, think about, just like in the last one, you're adding them to something. So maybe you're adding them to something that's even colder than ice, if you can imagine that. Which one is going to warm up that thing better or warm up that thing more? A pile of snow or a large cup of hot chocolate? But you have to be adding them to something colder than the pile of ice or the pile of snow. Otherwise, that wouldn't you wouldn't get the same results. So let me know if this video is helpful. You can comment with questions on the I'll post this onto Schoology and I'll try to answer those for you. Again, watch it as many times as you need, reference other resources online as you need, call up a classmate, ask them if they understood it, talk to your parents, and then we'll definitely spend time in class on Thursday going over all of this and making sure everyone has a good handle on it. But I really appreciate you guys getting this done, and I hope you enjoy your extra homeschool days this week. Bye.